Now that we know the derivative of ln to the x is 1 over x, we can actually find the derivative of more complicated ln functions. So you should have these questions on your sheet there, so we'll just quickly run through them. So the first one, if f at x equals ln of x, then of course f prime at x is 1 over x. Done. So we know that one. Okay. For b, we're doing ln 7x. So this is going to be very similar to some of the rules that we had before. So for starters, we look at it and say, guess what? This is a ln function. So ln of whatever is 1 over that thing. Okay, so if it's ln of x, it's 1 over x. If it's ln of 7x, it's 1 over 7x. The only catch is we have to do the chain rule. So since we're doing the ln of something, it's like doing something outside the brackets. Then we're going to do the thing inside. So we're going to actually have to differentiate by 7x, and that makes it 7. It's the same as if we had 2x plus 1 to the power of 5. And we're differentiating that. It's 5, and you leave it as own. You do that rule first. Then you differentiate the inside, so it's 2. Okay, so for ours, it's the same idea. Who cares what it is? It's the ln of 7x, so it's 1 over 7x. Then you differentiate inside, and the derivative of 7x is just 7. Now this is going to make things a little bit easier. 7 is 7 over 1, so times 1 is that, and then 7x. And then notice that this will cancel. And so it's 1 over x as well. It's not always going to cancel to 1 over x. However, there is a reason why this one, the derivative of ln x and the derivative of 7x, is also 1 over x. It sounds like a pretty good thinking question later on. Okay, let's look at C. Again, don't forget the rules that applied before. So if I had a question before that would have been 5x squared, I differentiate the x squared part, and I actually do this. Right, I differentiate x squared and I get 2x, and then the 5 and the 2 get multiplied together, and that's why I get 10x. But really I differentiate this, and the 5's just hanging around. Same thing here. If I'm going to differentiate this, it's 5 times, and now I differentiate ln of x minus 1. Well, I don't care what it's the ln of, the derivative is 1 over that same thing. But remember, I now have to differentiate that bottom, and the derivative of 1 minus x, or x minus 1 is just 1. So I'm writing it down even though times 1 doesn't change things. Now I can simplify. This is 5 over 1, this is 1 over 1, so on the top I have 5 times 1 times 1, so it's 5. I have the 1 times x minus 1 times 1, so it's just that. And then D, same idea. I've got a couple of things that are familiar. First thing, I want you to look at this. Ln of 2. That means what exponent do you put on e to get 2? There is an answer to that. There's no x here. Ln of 2 is actually a number. If you punch it in your calculator, you'll get some decimal. So pretend this is just some decimal. What's the derivative? Let's pretend the decimal is, I don't know, 3.64, whatever. What's the derivative of 3.6? It's 0. Why? Because this is a constant. Doesn't look like it, but it is. Okay, it's just there is an actual number that you put on e, an exponent that you put on e to get 2. Whatever that number is, you now differentiate that. Guess what? The derivative is 0. Because the derivative of all constants is that. Don't see any variables, don't see any x's there, so it's just 0. Now the second part of it is an actual function, and so I differentiate it. So again, it's ln, so the derivative is 1 over 2 to the x cubed times, now I differentiate the actual thing, and that's 6x squared, I can simplify things. This is over 1, so that's 6x squared is on the top. 2x cubed is on the bottom. And I can simplify things a little bit. 6 divided by 2 is 3. And x squared and that. So I'm going to have a minus 3 on the top and an x on the bottom. And that's the derivative of that function up there. One thing I'm just going to mention while I'm here, remember that ln x doesn't equal 1 over x, okay? Sometimes I see a lot of people when they're doing questions later on, they get so used to doing this. Ln x doesn't equal 1 over x. The derivative of ln x equals 1 over x. Okay, and this is going to come in handy later on when we're actually doing more complicated questions. Sometimes people just look at x and they replace it with 1 over x. You only replace it when you take the derivative of ln x. They're not the same thing. Okay? So you're going to do lots of practice today about taking the derivative of ln or different lns. And we're also going to answer this question. Remember, this question I promised would be on every one of your tests. Find the equation of the tangent to the curve. And this time, this curve or this function has lns in it. So it's the last question on your sheet. So we'll go ahead and actually answer it. So remember, the slope is going to happen when I differentiate. So m is going to happen when I differentiate. So this I see is a quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top. So the derivative of the top is 1 over x, because ln x doesn't equal it, but the derivative of ln x is 1 over x. So the derivative of the top is 1 over x times the bottom as is, minus the derivative of the bottom, which is just 2. Derivative of that is 2, times the top, which is ln x, all over the bottom squared, so 2x all squared. Again, this is one of those spots where sometimes people go off and substitute this. That's not right. That would be wrong, okay? We've already differentiated. We've taken the derivative. We're left with this, okay? So don't make that substitution. It's just ln x, just like it's an x or an x squared. I can simplify things a little bit. See, 1 over x times 2x, that's going to be gone. So up there I'll have a 2 minus 2 ln x. And even though I don't have to, I could make that 4x squared, but I'll just leave it as 2x all squared. Remember, I don't need to go much further. So this is the derivative. This represents all the possible slopes of tangents, but I only want the one where x equals 1. So I want the one where x equals 1. So I'm going to plug in and find the slope at 1. So it's 2 minus 2 ln 1 over 2 times 1 all squared. Now on the top there, this is 2 times 2. What's the ln of 1? Well, remember, ln means log base e. So it's saying what exponent you put on e to get 1. Well, it doesn't matter what exponent you put on any base to get a 1. The answer is 0. So ln 1 is 0. This is just 0. The bottom is 2 times 1 squared is 4. So that's 2 over 4, or 1/2. So the slope is 1/2. I've got this much, which means I've got y equals 1/2 x plus b. Now I've got to figure out my x and y point so that I can sub it in here. So x equals 1, we're going to sub into the equation. So it's y equals ln 1 over 2 to the 1. Well, again, ln of 1 is 0 over 2, so it's just 0. So the coordinate is 1, 0. That's the coordinate we're going to sub into this function. Should make our math relatively easy. Y is 0, half times x, which is 1. 0 equals 1/2 plus b. Subtract 1/2 by both sides, and I get b. And therefore my equation is y equals 1/2 x minus 1/2. Again, this is just practice of finding derivative of ln x. So today you're going to do a couple of practice questions out of your textbook from taking the derivative of ln. And because this is so important, tomorrow you're actually going to differentiate a bunch more. Differentiate a bunch of e to the power of x questions and a bunch of ln to the power of x questions. But this one, just worry about this today. A couple of practice questions for you to try. Good luck.